Welcome to the session on isometric projections. Now in this chapter, let us try to understand how to draw the isometric projections of the various models that will be given, or with respect to the text that will be given in the questions. Before going into the isometric projections, let us understand what is meant by isometric scale. Let me teach you how to draw the isometric scale. This is very important to get the isometric projections of any of the models given. First, you draw an horizontal line OA at any one side of the sheet, preferably at the top right hand corner. Then draw a 45-degree line OB, which will be where you are going to mark the actual scale, either in centimeters or in millimeters. Now you are going to draw another line called as isometric scale, which makes an angle of 30 degrees with the horizontal OA. This is where you are going to mark the actual length. This is where you are going to get the isometric length. Now mark the actual centimeters all along the length of the line in terms of either centimeters or millimeters. So now you have marked it 0 to 10 centimeters all along the length of the actual scale along that 45-degree line. From here, you drop the verticals to cut the isometric scale. You can see the vertical drops. You're going to mark this distances as 1 dash, 2 dash, 3 dash up to 10 dash. Normally this distances, when it is measured or calculated analytically, it will be 0.816 times of the actual length. And this is the easiest way of getting the isometric distances, which is very important to draw the isometric projection. That's all about isometric scale, which is very important for plotting the isometric projection. Now let us try to understand what is the difference between isometric view or isometric drawing, also called as isometric drawing, and the isometric projection. Now if any model, I'll take an example here, is plotted by keeping the sides at an angle. Always the isometric drawing, we are going to draw the horizontal line, these lines which are called as OX axis, OY axis and OZ axis, which will be perpendicular to each other, and these lines will be drawn at an angle of 30 degrees, and the model will be drawn here. I'll teach you how to draw each and every line of this isometric view. Now here we want to understand the difference between isometric drawing and the isometric projections. So whatever the model that has been given will be plotted to the actual length. So whatever the length that is marked here will be the true length. If 30 mm is given, we'll mark 30 mm. If this is equal to 80 mm, 80 mm length will be marked. And if this is equal to say 20, we are going to mark 20 mm as given in the questions. If this figure is drawn to the same scale, we call this drawing or view as isometric view or isometric drawing. Now let us understand this is actual lengths, what you are going to plot. All this length are true lengths, actual length. Let us try to understand what is meant by isometric projection. Here also you're going to draw the isometric axis OX, OY, OZ called as isometric axis. If any lines are drawn parallel to this axis are called as isometric lines. All these lines, now this is parallel to this 30-degree line, and these lines will be parallel to the 30-degree line, therefore we call them as isometric lines. If any other line is inclined which are not parallel to this 30-degree line or parallel to the horizontal line, then we are going to call that line as a non-isometric line. To get the non-isometric line, we have to mark the isometric lengths and mark this one. We'll understand all these things when I start up with the problem. Now understand the difference between isometric view or isometric drawing and isometric projection. This model has been drawn to the actual length or true length. This drawing is drawn to a diminished length. Whatever the scale we got it from the isometric scale, whatever the isometric length we got it from there, it has been plotted. This lengths are the reduced lengths which will be of 0.816 times of the actual length. It is a very time consuming one. Every time we cannot measure it. Therefore, we are going to draw the isometric scale first. From the true scale, we are going to convert this into isometric scale by drawing the verticals on the 30-degree line from the 45-degree line as you observed earlier. From there, we are going to get the distances and we are going to mark the distances along this isometric lines or isometric axis. Those lines which are drawn parallel to the isometric axis are called as isometric lines. Now let us try to understand how to draw a circle so that once you are used to this, then it becomes very easy to draw any problem or a model with either a circle, an opening, or if it is a quadrant or a semicircle, anything. The procedure what I am going to explain now is very important. There are two methods are there to draw the circle. One is 4-center method, other one is offset method. Now I want to draw a circle in an isometric view. So what you are going to do, draw a circle, first plot it on one side, draw a square box for that, where the sides will be the diameter of the circle. Now you just mark this, name it as P, Q, R, S or ABCD or whatever you like. So the circle has been embedded with a square and we have named that as PQRS. Let us try to understand which side we have to plot it, whether along OX axis, which is a left view, OY axis, which is a right view, or was the top view, XY plane. Now let us try to understand those planes here. We are going to draw always 30-degree lines which are nothing but the sides of a circle. Complete that square. You mark this as PQRS, PQRS. Now just making it a cube so that you can understand the different planes. I'll name that one also as P dash, Q dash, R dash and S dash. They are made into different planes. I just taken a cube into consideration so that you can understand the different planes. Now I'll call this as a front view or the right view. I can call it as a front view or right view. So what is the right view or the front view? It is P, Q, Q dash and P, this plane. So if I want to draw the circle on this plane, We can draw it. We'll explain you in the later cases. Only to make you understand the concept, what is meant by front view or right view, I have shown it. Now take the left view. This is the left view. You can see here. It is P, S, S dash and R, P dash. This is the left view, left plane, profile plane. Now let us understand the top view. It's nothing but P dash, Q dash, R dash, S dash. So this is the right view, the left view with a green color and brown color with the top view, for the top view. So we can draw the circle on this plane. We can draw the circle on this plane, draw the circle on the top view, either at the top of the whatever the shape you consider, and at the bottom, anywhere you can draw it. Let us try to understand those things in the problems that we are going to solve later. Now let me take the first case where I want to draw the right view or the front view. So I'll draw an horizontal line. Draw this 30-degree lines, the mutually perpendicular lines, which makes an angle of 30 degree. Now let me draw the first line PQ on the right side and draw this square PQRS by erecting the verticals and getting the plane. PQRS is the required plane to draw the front view or the right view. So now the procedure of drawing is very important, where we're going to draw this by 4-center method, which is one of the easiest method. I'll give you the procedure also, how to draw it, all those things. Go through this again and again and be mastering this before going to draw in any of the problems, models. Now you join the diagonals PR and QS. In these two diagonals, consider the shortest diagonal, that is SQ or Q. Yes. Now you mark the midpoint. First you mark the midpoints of the sides. Call them as A, B, C, D. Now consider the shortest diagonal. In that, shortest diagonal is SQ or QS, whatever you call. You draw the radius line like SB, SA, means join SB and SA with SB as a radius and S as center. You draw an arc. With S as center, SB as radius, you draw an arc BA. Similarly, take Q as the center, draw the radius line, that means join QD, QC, join this. This acts as a radius. Either consider QC as radius or QD as radius. Draw an arc with Q as center. With Q as center, QC or QD as radius, draw the arc CD or DC. Now you get these 2 points where the diagonals are meeting. Diagonal and the radius of this arcs are meeting. You mark them as O1 and O2, the intersection points. Mark them as O1 and O2. With O1 as center and OD or OA, O1A as radius, draw an arc DA or AD. Draw this arc. O1 is the center, O1D is the radius. You want to draw the arc. Similarly, O2 as radius, O2C or O2B as radius, you draw an arc to get CB or BC, whatever you call. This is a required circle which looks like an ellipse. The circle will be converted into an ellipse. You are seeing an enlarged figure here, but actually it will be smaller than this actual scale, a diminished dimension, where the circle will look like an ellipse, where the isometric lines will be of a diminished size of equal to 0.816 times of the actual scale. And this is the procedure of drawing. So whatever the procedure I explained holds good even for drawing the semicircle or the quadrants. We'll try to learn those things when I take up the corresponding problems with semicircle and quadrants. Now let us try to understand how to draw the left and the top view. So first draw the horizontal lines. Complete the square on the left hand side. So I'm going to take this corner. This is the left view I'm going to mark. So this is Q has been kept here, R is here, and SP on the other side. That means I'm considering this corner. In the previous case, I considered this corner. So I've drawn the left plane to draw the left view of the circle. The procedure of drawing this circle to get in the form of an ellipse is the same as what it was explained earlier. So join the diagonals. The diagonals are PR and QS. With these two diagonals, consider the shortest diagonal PR. That is important. So before drawing the arcs, you mark the midpoints of all the sides. Name them as, say, A, B, C, D. Midpoints of all these things, all these side edges. Now consider the shortest diagonal. Mark PB and PA, as well as mark QC, RC and RD. Now with either RC as the radius, R as center, or RD, either you draw the arc from bottom to top or top to bottom, you draw an arc. The radius is RC, R is the center, you draw an arc CD. Similarly, you join PB and PA. Either PB as radius or PA, which are both are same, you draw an arc BA. P is the center, PB is the radius, you draw an arc BA. Now this radius lines will meet the diagonal QS at two corners, two centers, here one. Take this as center, I can call this as, say, O1 as center and OA as the radius. You draw an arc. I have not named it, but you can read that as O1, the center. Now consider this center as, say, O2. You can draw an arc. BC. This completes the left view. Similarly, we can draw the top view. Mark the sides PQ and QPS. The other side QR and SR. You draw on the top view. So consider that this corner. Join the diagonals. Mark the midpoints of all the sides. Now join the line, take that as radius, that is to draw the arc, PC as a radius or PB. Draw an arc CB. Now from R, you draw a line and join RD and RA. This will meet at these 2 points, can be called as O1 and O2. Now you draw with R as radius, RD or RA, R as center and RD or RA as radius, draw an arc AD or DA. Now with this as center, radius equal to, if I call this as O1, O1D or O1C, you draw an arc. And similarly, you can draw an arc with this as center, an arc BA can be drawn. This is the procedure of drawing a circle. Very important for drawing the cylinders, the cone, or any problem with combination of those things can be drawn. Now let us take one typical example, how to draw a cone which is having a diameter of 50 mm and height 60 mm, which is resting on HP. Now you can see the 3D model of a cone here, which has got a diameter of 50 mm and the height from the center of the base to the apex is 60 mm. Now this cone has to be drawn here in an isometric view. So to draw that, first let us draw a circle on one side of diameter equal to 50 mm and draw a square for this. Name this part so that it becomes easy for you to draw the isometric projection, not isometric view. So whatever the distances that we are going to plot here, this is the diameter of 50 mm, or it will be converted into isometric scale. There is no need to say this every time. It is understood. Whenever you want to get the isometric projection, whatever the length you measure, the isometric lines you are going to measure shall be taken from the isometric scale. All the problems, whatever the problems you are going to solve in this chapter, or we are going to learn it, will be marked with isometric scale. If you want to have the isometric view, there is no need to take the isometric scale. Whatever the 50 mm is there, same thing, you can plot it and get the view that is called as an isometric view or isometric drawing. Now let us draw the isometric view projection of a cone having 50 mm as diameter and 60 mm as height. Now as usual, draw the horizontal line, draw the sides PQ and QS, complete the square PQRS by drawing the parallel lines parallel to 30 degree. This completes the square, the base part of the cone. Okay, so as usual, the procedure of drawing this is by drawing the diagonals, marking the midpoints, and considering the shortest diagonal, PR. You can join these lines. As it was said earlier, I can name this as say ABCD, or I can join it to the opposite side, center of the opposite side. So from P you are drawn to the center of QR. From P you are drawn a line to the center of RS. Now with the radius, this radius, you draw an arc. Every time I am not naming all these things, I am just explaining the procedure of drawing it as it was done in the earlier cases. Now draw the other diagonal line which joins from the center R to the opposite side, center of the opposite side. With this as the radius, you draw an arc. Now you got the two centers here and here. You complete this smaller arc. This is the center, radius equal to this length, you draw an arc. Similarly on the side, this completes the base of the cone. This is a circle, it is now become the ellipse. You have completed. Mark the height of this cone, 60 mm from the center, from the isometric scale. From the isometric scale you have marked the 60 mm height, length. Now draw a tangential line from this apex point, draw a tangential line to the base of the cone. You are going to join it by an apex end generator which is tangential to these arcs. This completes the cone. Now whatever you see here, this part could be seen. There is a front face and you cannot see the inner part. You can show it by dotted line. This portion can be shown by dotted line, or you can leave it blank. You can show it by dotted line, or else you can leave it blank. And this one front side will be marked with thick line like this. This completes the drawing of an isometric projection. The complete drawing has been drawn to isometric scale. Thank you for watching this video. If you like it, comment on this. If you are not subscribed, kindly subscribe now. Thank you very much.